Hello, today we'll start with the final part of module 1, which is the integration part. Let us start with the average value of a continuous function. So if f is a function which is integrable on a comma b, then the average value over a comma b is given by this formula here, where we say the average of f equals 1 by b minus a, integration from a to b, f of x dx. To find the average value of f of x over here, 3x square minus 2x on 1 comma 4 is an example. Your f of x is given as 3x square minus 2x, your a is 1, your b is 4. So we can take your average of f using this formula, 1 by b minus a, 4 minus 1, integration from a to b, 1 to 4, f of x dx. Similarly, we can do it for a trigonometric function or any other function. Over here, your a is 0, your b is pi by 2, and your f of x is cos x. Same formula. On solving, you get your value of 2 by pi. Then we have the fundamental theorem of calculus. Fundamental theorem of calculus states that if f is a continuous function on a comma b, then f of x, so big F of x, equals integration from a to x, a is some constant, f of t dt, is continuous on a to b. So given that the f of x, the big F of x, the integration is continuous on a comma b and differentiable on a comma b, then the derivative f of x, so your derivative, if we are representing with f of x, so the derivative of this integration. So over here, this is not a function of x, this is a function of t, small f of t, right? So then we say the derivative of this integration is equal to f of x. So over here we have the example, as you can see. Find derivative of y dx. So derivative of y with respect to x if y equals integration from a to x t cube plus 1 dt. So again, by fundamental theorem of calculus, it's a to x and we're taking a derivative, so it's d by dx of this integration. So then we can directly see the answer is f of x, which is x cube plus 1. Over here we have integration from 1 to x square cos of t dt. By fundamental theorem of calculus, to use it, we need a value from a derivative from a to x, this is a to x square. So what we do is we let x square equals u, and if we take a derivative throughout, we get du by dx equals 2x. So now our y value is changing from 1 to x square to 1 to u. Cos of t dt remains as is. In dy by dx, we can use the partial derivative or chain rule. We get dy by du into du by dx equals, so your dy by du will be given by your derivative with respect to y of this function. Over here, you can use fundamental theorem of calculus giving you cos u. Your du by dx, you know, from here is 2x, so that's how you get 2x. But you know u equals x square from here. So then at the end we just substitute, we get 2x into cos x square is your answer. Moving on, we have area between curves, definite integration. Now how to solve a question of area between curves? Firstly, we must subdivide a and b at zeros of f. So we need to find the zeros of the function. Then we need to integrate f over each interval. So then this will subdivided groups will have the value of the function integrated in that subdivided group, and then we add the absolute values of the area. We can take one example over here. Find area of region between the axis and graph of f of x equals x cube minus x square minus 2x between minus 1 and 2 when x lies between minus 1 and 2. So f of x equals this function. We can take x out common from the function. Now find the zeros, we need x times this should be equal to 0. We equate f of x to 0. So from here we get x is 0, and if on solving x square minus x minus 2 equals 0, we get x is minus 1 and x is 2. So now we are integrating from minus 1 to 2, f of x dx equals equals integration from minus 1 to 0 f of x dx, this I'll call a, and integration from 0 to 2 f of x dx, which I'll call b. So a equals integration from minus 1 to 0, x cube minus x square minus 2x dx. On integrating, we get 5 by 12. Integrate part b from 0 to 2. So then we get this over here, which gives you an answer minus 8 by 3. But to get the area, we need to add the absolute values, as you can see in step 3 here. Add the absolute values. So we are taking the absolute value of b, we take 8 by 3, and the total area is given by this minus integration from minus 1 to 2 f of x dx, but that is equal to a plus b. So over here we get 5 by 12 plus 8 by 3 equals 37 by 12 square units is your area. Then here we have find area between the curves f of x equals 2 minus x square, g of x equals minus x, and you have to find the area between the curves. So your curve 1 is a parabola, 2 minus x square is a parabola, g is minus x is a line with slope -1. So now we have to find the zeros. For the zeros, we take the point of intersections. We equate both. So minus x equals 2 minus x square. On solving, we get the point of intersection as 2 and minus 1. Now when is x is 2, we can see your y value is minus 2. So we're finding the exact points of intersection. That's it. The area between the curves A, we take from -1 to 2 since those are the points of intersection, and we're integrating with respect to x. Now for this definite integration, we have to take the area between the curves, right? So that's this area over here. For that, we take the area enclosed by the upper curve minus area enclosed by the lower curve, and that will give you this area remaining. So that's what we have done here. We are taking area of upper curve minus area of lower curve, and the entire thing we're integrating from -1 to 2 with respect to x. And the answer we get is 9/2 units.